computer. All right. Here we go. Rick, you're up.
All right. Well, so I've been playing with telescopes for quite a while, and get my PowerPoint notes come up. Whoops. There you go. Got it where I need it now. All right. So I've been playing with telescopes for quite a while, and when I first got started, this was my telescope, and the only thing I needed power for. Y'all see my screen? Yeah.
Oh, yes.
Do you see my cursor when it's on the screen?
Yes.
No, you don't, do you?
Yeah, I do.
Yeah, we see it.
Okay.
We do.
All right, good. So this was, in fact, I still have this. This is my first portable battery, and it's a, just off the shelf. It's a 7 amp hour, 12 volt, 7 amp hour battery. These things are in all kinds of uninterruptible power supplies and emergency lighting fixtures, and they're all over the place. They're cheap. They're $20 for the battery. This comes with a charger. It's got a cigarette lighter plug on the end of some wires, and I used to hang this strap over the back end of my mount right here and plug its clock drive into it, and that's all it had to run, and it would do that all night for days at a time. It was plenty of power, all I needed. And when I started doing astrophotography, my Canon F1 takes no batteries. You can stick a battery in it if you want the meter to work, but even the meter didn't control anything. You used it. It was a match needle. You looked at it and adjusted your settings manually, but the camera was completely manual. So what I want to talk about is battery packs and power supplies. And what I want to distinguish between a battery pack, a power pack, and a battery is that power packs like this and this can have multiple output voltages, right? This thing's got a radio, for God's sake, I don't know why. Of course, a couple of lights. It's got some low voltage outputs. I forget what these are, 7, 8 volts, something like that. A couple of cigarette lighter jacks, and whoops, sorry. And then this was actually my second power supply after this one. We had a member of the Memphis Astronomical Society, lived in Jackson, and drove all the way down to our meetings every month. And he had some of these. I think he worked at a warehouse or something and got a deal on them. For all I know, he stole them, but I paid $100 for that. And
hey, Rick, we lost your presentation.
Oh.
At least I did.
No,
It's still good here.
I got it.
No, okay. So it's mine.
Okay, sorry.
It's me, not you. It's not you. It's me.
Freddie didn't pay his Comcast bill.
Exactly.
So this thing's got 2 of these 17 amp hour 12 volt sealed lead acid batteries in it. So that's 35 amp hours at 12 volts. And this thing's also got a AC inverter on the back of it, and it's got 220 volt outlets here on the front. And I used that for many years, and I've since replaced the batteries in it actually a couple of times. But here's a new one. Oh, geez, he's clicking my mouse. This is one I acquired recently. This is lithium. I don't know whether it's iron phosphate or just plain old lithium, but it's got a 12 volt outlet and a couple of 120 volt outlets. and it's a 250 watt hour rating, and that's really what you want to pay attention to. If you ever get something like this, and it tells you a amp hour rating without telling you the voltage, then it's a meaningless thing. And I have seen some battery packs advertising amp hour ratings without specifying which voltage they're talking about. So an amp hour, for those of you that haven't figured all this out yet, is a measure of electric charge. And essentially, in that small 12 volt, 7 amp hour battery, it could deliver 7 amps at 12 volts for 1 hour, or 1 amp at 12 volts for 7 hours. And that's essentially what it means. It's how many amps per hour that you can get out of it until it's gone. And then sometimes I think some people don't understand what the least charge you can get, where the voltage should be on a battery when it's fully discharged. And I've seen a lot of lead acid batteries become much shorter lived and are essentially ruined because they get fully drained. And this can happen in your car. You know, if your car battery completely drains, where it goes down to 1 or 2 volts, that battery's half its life is gone the day that happens. You can recharge it, you can get it back, but it's not going to last as long as it should have. And car manufacturers have never taken the bother to take care of that. It wouldn't be that hard to do. For a 12 volt lead acid battery, full discharge is about 10.5 volts, and you should never discharge one more than that. So like I said, an amp hour rating without a voltage is meaningless, and what you need is watt hours for that. So a watt hour is a measure of electric charge. However, watts are a combination of volts and amps. So if this same power supply I was talking about is a 250 watt hour rated battery. So with 120 volt, 12 volt, 5 volt DC outputs. So essentially at 120 volts, you can get 2 amp hours of power. So that's basically, 1 amp for 2 hours or whatever. This is what we plug the TV that we use for Stellina in, and that TV draws about half an amp, half to 3/4 of an amp. So this thing will run it for maybe 3 or 4 hours. 12 volts, 250 watt hours is going to be 20.8 hours. So 12 volts at 1 amp for 20 hours, and 5 volts, a 5 volt 1 amp draw, it'll be good for 50 hours. Now, at 5 volts, something like 10 watts is 2 amps, right? So typically things at lower voltages, the current draw is going to be higher. So as time went on, my power requirements increased. I started doing a lot of video work, and I'm recording with a TV, VCR. This camera's run into an 8mm videotape player. It had to run the clock drive, and also a WWV radio, because we were doing occultation timings, either asteroid or lunar occultation timings, and trying to get all that recorded. And I did a lot of that, and that's where I started using this power supply. So to get back to battery chemistries and how things have changed over the years, I'm not going to talk about dry cells. I'm not going to spend any time on NiCad or nickel metal hydride. I am going to talk about lead acid batteries, lithium ion lithium iron phosphate, and a little bit on lithium ion. Lead acid batteries have been with us since over almost 200 years. The first rechargeable lead acid battery was built in 1859. A standard car battery. This is essentially the different varieties of lead acid batteries that are out there. That, you know, everybody's got a car battery in their car, and these are designed to produce a very high current for a short period of time to run the starter. They are not good at deep discharge that will shorten the battery life. It's all in the physics of how the battery's made. It's how many plates they've got in them, how thick the plates are. These starter batteries can put out up to 800 amps for 2 or 3 or 4 seconds at a time. That's another thing too. If your car won't start, don't just keep cranking and cranking and cranking. You know, crank it for about 5 or 10 seconds. If it don't start, back off and try again in a couple of seconds. Give the battery a chance to cool down. A marine deep cycle battery, these typically can start an engine. They're not the greatest at it, but they also are a lot more tolerant of deep discharge. So these are used a lot in RVs and boats, where you'll have essentially 2 batteries, one for starting the engine, and then say a deep cycle battery to run all the other electronics on the vehicle when when the engine's not running per se. Also used to run trolling motors on fishing boats. Another design of lead acid batteries are gel cells. These were used a lot in large uninterruptible power supply systems, big battery banks for major computer control rooms and stuff. They're very stable. They can suffer discharge pretty well. Dog had to climb out from under my desk. And then they're rugged. They don't leak. They're very low maintenance. Absorbed gas mat, you might see these kind of batteries. You go shopping for a car battery. AGM batteries are very rugged. They have the electrolyte is embedded in like some kind of foam-like material between the plates, so it's not just sloshing around in the battery, and the plates stay in place, and everything is much more rugged with these AGM batteries. So they're used a lot in boats and off-road vehicles. Then for our purposes, sealed lead acid, these are going to be the small batteries, like I've shown pictures of already. They're can be positioned in any position, upside down, sideways, turn over. They're not going to spill any acid out unless they become broken, and then they can. So that's an issue. And they are typically good for deep discharge, and not they'll have some current limitations, right? So you won't be able to get 800 amps instantly out of one of those batteries. So lead acid battery, pros and cons. Basically, and it's still true, your best cost per amp hour is lead acid batteries, period. They're still used in big industrial uninterruptible power systems or battery backup systems. Lithium is starting to replace those, but hasn't really done it yet. Gels and sealed or maintenance-free batteries, again, are still in wide use. The cons are you charge a lead acid battery, you get hydrogen gas. So that's an issue you just need to be aware of. For sealed lead acid batteries, it's not typically anything you need to worry about. for other batteries, including the one in your car. If you're recharging it and the hood's closed with a high current charger, and you're trying to get it recharged from a dead state, be careful. You know, put your cigarette out before you open the hood. That's all I'm saying. The self-discharge rate on lead acid batteries is pretty high. So you take a 12-volt lead acid battery and sit it on a shelf, and in months it will be it'll discharge itself to the point of needing to be recharged. And if you leave one sit for too long, it'll discharge below its below that minimum charge amount, and you can shorten the life of the battery. Oh shoot, sorry. The discharge state of the electrolyte makes it more water than sulfuric acid. The electrolyte in a lead acid battery is sulfuric acid and water. The more discharged it becomes, the less the sulfur goes to the iron plates, and what's left is more water. And you can actually freeze a standard lead acid battery in the wintertime, which can bend or break the plates, can cause other damage, and seriously ruin a battery. I've already talked about letting it discharge below 10.5 volts. They are heavy, and of course acid can be a problem if they are damaged or spilled. So best practices: don't discharge below 10.5 volts. Recharge after use. Do not store in a discharge state, and get a good quality trickle charger if you're going to store one. You can, with a good quality charger, you can leave it on the trickle charger all the time, but most trickle chargers are not what I'm talking about. It's going to take a smart trickle charger to be able to leave it on there all the time. You can use an inexpensive trickle charger, but you need to leave it on there for 3 or 4 days, maybe a week, and then take it off and let it sit for the rest of the month. Put it back on next month. If you're going to store lead acid batteries, I recommend checking them at least once a month to see what their charge state is, and get them back on a trickle charger. There are some good ones out there, trickle chargers. I'll tell you about that in a minute. So this is one of my gel cell batteries. This thing started as just a marine deep cycle battery in this case. And when it was just, I had a 12-volt cigarette lighter box that had 3 cigarette lighter plugs on it, and I had it wired to the battery. And that's what I used to use when I was doing setups like this, where I had all this gear is running off 12 volts. That battery was sitting in the back of the truck here, and everything was plugged into it. This is not what's in here now. This has been rebuilt several times. This is my most recent iteration. It's about 4 or 5 years old. This now has a gel cell in it. So this is a 100 amp hour gel cell. And in the lid, I put a volt amp meter. So this will read the present voltage and the current draw on the battery instantly. Attached to the outside of it, this is a charge controller. So I use this as a uninterruptible power supply of sorts for my ham radio station, but it's also makes it portable, so that if I need to go into portable ham radio operations, this radio is portable. I can go put it in my truck. I've got portable antennas. Take this battery with me. I can set it up. This is the charge. This is the power supply for the radio. So I use it to charge this battery through this charge controller. Then this is a power distribution block. So I've got a bunch of different 12-volt ports here that can power other 12-volt accessories, and including this 300 watt pure sine wave AC inverter that's strapped to the back of it. But this sucker weighs 76 pounds. That's a bunch, especially when you try to carry it outside. So why don't we not carry it? What kind of batteries should we use? Can we use? Lithium iron phosphate is rapidly replacing most of the batteries that we would normally want to use for the kind of portable power efforts that we're doing. For one, their weight is about 1/2 to 1/3 of a similar lead acid battery. They have many more charge cycles available to them. Their self-discharge rate is way less. And for the same size battery, you got 1/3 the weight. Lithium ion is a good battery too, and it's why the power density is why these are used in your car. These are 265 watt hours per kilogram versus 160 watt hours per kilogram, up to 693 watt hours per liter in volume, 325, so twice that. Problem with lithium ion, especially for amateur use, is that they come in a variety of chemistries. And these chemical variations, of course, change the voltage output of each cell. And charge controllers for these are critical. And if you're not charging it correctly and storing it correctly, these things can erupt into flames. And they have, and it is a known issue. And you have to do a lot of engineering to use lithium ion safely. Not so much with lithium iron phosphate. They're almost as hard to mess up as a lead acid battery. And the good news is these, as I was doing my research for this, I'm finding that this is a 7 amp hour lead acid battery, $20. This is a 7 amp hour lithium iron phosphate for $29. And it's got a built-in charge controller. So you don't charge a lithium iron phosphate with the exact same way you do a lead acid. But it looks like these are going to take care of working in the same application. So when you've got a battery you got an application or a power supply like one of these or some other application where one of these batteries has come out, you can replace it with a lithium iron phosphate to get way more cycle life out of it. And it'll take care of the charge controller, charge problems itself. These batteries, you're connected directly to the plates. This battery, you're not. In fact, you're not connected. You're connected to its charge controller, and you're not connected to directly to its plates. So these are starting to look really handsome now they're expensive, right? This battery is $40. This one's $75. This thing's got 2 of these in it, but it weighs 1/3 the weight. And this thing's not particularly light. It's not overly heavy, but it's about time for me to re-battery this thing. And I think I'm going to put in 2 lithium iron phosphates this next go around. Same thing with my gel battery. This thing is now 5 years old, and I really am quite amazed that it's still in good shape. 5 years on a battery is a long time, even when you're not using it a lot. This thing sits in a triple charge state most of the time. About the only time I really get any use is when I lose power at the house and the radio stays on for days at a time. But a 200 watt gel, I mean, a 100 amp hour gel cell was $200, and this was what it was 5 years ago. But a 100 amp hour lithium iron phosphate 5 years ago was $800, and it's now down to $350. For the extra $150, the next time this needs replacing, it's getting a lithium iron phosphate. And I should go through all that to tell you that you can find people that are throwing these away. You can probably buy some on eBay. This one was given to me. The batteries were dead. I put new batteries in it. It works fine. I've had it long enough. It's about ready for new batteries. I'm going to put lithium iron phosphate in it next time. These are also out there. These are good candidates for upgrading the batteries. The next thing about power in the field is the connectors, and I have I'm a big user of Anderson power pole connectors, the ones down on the bottom of the screen here. If you've ever set up a telescope that's got a go-to mount, and you go through an hour of getting it polar aligned, and then getting it aligned, doing a 2 or 3 star alignment, and you get ready, all that done, and you're an hour in already, and you're ready to start imaging or ready to start telling it to go to the next thing to look at, and suddenly this cigarette lighter plug wiggles in its socket and you lose power. That is just the worst thing that could ever happen, because now you got to start all over again. But the go-to telescope has lost its mind. So I'm not too fond of these at all, and I don't use them on my telescopes. Your telescopes will have a barrel type connector on them. Almost all of them use this kind of connector to plug in. They're okay, they're fine. There are the hassle with these is that there are so many different sizes, and when you go to make up cables, you got to get this outside barrel diameter and the inside pin diameter right. And if you don't, you've got another situation where it might work sometimes. If it'll fit on there, and let's say that inside pin diameter is too big for the pin you're actually using, you get lucky, it connects, it wiggles, it disconnects, you got the same kind of problem.
Also, you need to be careful about polarity on those.
Oh, yeah, right. So you might have one, most of the time the inside part here is positive and the outside barrel is negative, but there are occasions where it's the other way around. Then phono plugs, how they ever got to using these on dew heaters, I kind of get it. Ham radio uses phono plugs for a lot of stuff. It really ought not, it got nothing to do with phonographs. These are for hooking up your stereo gear. I don't know why they use them for dew heaters, but they do a lot. So those are out there. I change everything to Anderson power poles. These connectors provide not just a very positive connection, but the amount of metal that actually contacts between these makes these capable of dealing with a lot of current. This is really a pretty small connector, but it's 30 amp capable. So this is what's used to hook up the batteries in most uninterruptible power supplies and any other industrial applications where you've got low voltage DC connections that need to be made. So I'm a huge fan of them. I have all the tools you need to crimp on those connectors. I've got dozens of connectors and different sizes for different wire sizes. There are a couple of, this is the website of the company that manufactures them. They don't sell them. They're the manufacturer. PowerWorks is a big seller of Anderson power poles, tools, and equipment and stuff that they're not expensive. And you get a whole bunch of connectors cheap, but you got to put them on yourself. So West Mountain Radio has got some wonderful charge controllers and other components. You can set up a thing where you can use solar panels to charge your batteries instead of having some other kind of power supply. They've got they know how to treat batteries. They've got all kinds of battery test equipment, battery maintainers, equipment for dealing with that. So this is my first soiree into using a lithium iron phosphate battery for telescope work. I found these. I think when I first bought this, it was $49, not $59, and for 16 amp hours at 12 volts, that was as cheap, almost as cheap as sealed lead acid. And I bought one and I threw it in a box like this. I put in Anderson power pole connector block here, and this is a little voltmeter charge indicator, and I hooked it up to the battery and used it a couple of times out in the field and left something plugged into it and turned on and ran the battery down. And when I did, it killed the battery. The battery was dead. I've tried to put the charger back on it. It wouldn't take a charge. It was just dead. My first working with a lithium iron phosphate battery. So, but I really liked how light this was. This was 5 pounds or less. It really was nice. So I bought another one. And then I found out that when a lithium iron phosphate battery does that, because of its internal controllers, it shut itself off. And to get it to reset, you've got to hit it with a pretty healthy reverse 12 volts. So I basically took another battery and reverse polarity hit it with a charge, and it came back alive, and I was able to recharge it at that point. Well, but I'd already bought another one, so now I have two, right? So I thought, well, I just need to make me another battery box that holds two of these. So now I've got two 16 amp hour batteries, so basically about 32 amp hours at 12 volts. And this is my battery box, and it's every bit of 11 pounds and has all the features I wanted. So I've got power poles. These are direct connect to the battery. Now these 16 amp lithium iron phosphate batteries, I think I don't remember what the maximum current draw was. I think it's somewhere in the neighborhood of 30 amps. So I wired this thing for 30 amps. I can get 30 amps out of here. So this is what I would hook up to my ham radio, because my ham radio at 100 watts output single sideband is going to draw about 20 amps. So if I'm using this to temporarily power my ham radio, that plugs in here. Now, it turns out my telescope mount was kind of voltage persnickety. So you get down below 12 volts and it didn't really want to act right all the time. So I thought, well, that's easy enough to fix. I can get some boost inverters and put in a couple of 7 amp boost circuits. So no matter what the battery voltage is, down to about, well, I wouldn't let it go below 8 volts, but anything that the battery's putting out comes out of here at 14 volts. So no matter what the battery rating is, and this is going to show me my direct battery voltage, no matter what it is, down to 8 volts, I'm going to still get 14 volts out here. So that's what these two circuits are for. This circuit I needed for my iPad. So about this time is when I got my ASI Air, and I run all my telescope stuff now with ASI Air from my iPad, and my iPad battery won't last all night, so I can plug in a USB-C cable there and run my iPad. It's also got a 12-volt cigarette lighter outlet. This is a kill switch, so once I hit that switch, everything shuts off. Whoops. This is, so, you know, I'm having fun. I put a push button here and a couple of lights, red LED lights there, so I can light everything up. Here are the two batteries in the box. This is a fuse block in here with different fusers for the different circuits. Stuff some high density foam around the batteries to keep them in place, close the lid, and the thing works great. It's all got weather covers over them so it could sit out in the rain if it had to.
You have the batteries in parallel, Rick?
Yes.
Okay.
Yeah. These two connectors actually are there. They connect directly to the batteries so that I can, I don't have to dig them out to, Jesus, why does it keep doing that? I don't have to dig them out to keep, to hook up a good voltmeter to them and see what the state of the batteries really is. Oh, this right here is this is where I plug in my charger. So I'm a big fan of C-Tech battery chargers, and I'll talk about those in a minute. But this is they're made for cars, and mostly there's the application. And this is a charge controller that or an interface basically you stick in, you mount in a car, and you plug the charger in under that rubber cap, and the little lights there flash about once every couple of seconds at full charge, just to show you that it's fully charged, and it doesn't draw it draws very little current, so I can sit there for months and months and do that. It's not going to do anything, but it makes it easy to recharge the batteries. And I've had that map light for 30 years, so I always loved that thing. This is a C-Tech battery charger. You can see it plugs in here. This is a lithium ion battery charger, and it's designed specifically to take care of. It's not just a trickle charger. If you leave this sitting on a battery, and I have them for lead acid batteries too, because I use them for my cars, it will maintain the battery. It will know that it's been trickle charging it for forever, and it needs to drain it some before it starts up, and it'll run through these patterns of charge and recondition cycles to take care of your batteries. A lot of car museums, car places that keep cars stored for long periods of time but try to keep them in running condition will have these battery chargers on them. They're not cheap. These are about a little over $100 a piece, but they're great battery chargers. I have ruined a whole lot of batteries in my life with cheap battery chargers. I have never ruined one with one of these. Well, this whole Anderson power pole thing yields itself to a whole lot of versatility and use, and that's one of the reasons for it. You see, all of these pieces have got Anderson power pole connectors. So if I need another cigarette lighter outlet, here's one on a cable with Anderson power poles. If I need to run my 300-watt pure sine wave inverter, it's got a power pole connector on it. Here's a cigarette lighter block. This is the one I used to have stuck on that other battery case that I told you about. It now has power pole connector on it, so I can plug it in here, power it. Here's a cigarette lighter cable with power pole, so I can just put those together and use it as that. That's actually a USB-C cable for my iPad. All this stuff goes in this box and this box. They go together, and it's my complete portable power system there. In fact, this is This is a 5-volt DC for USB output there. This is just another power distribution block. And that's that. So that's a versatile power distribution system. These are the schematics and parts list for my box. And if anyone's interested, I actually have a PDF of this. I'm going to put up on our Slack channel, and you're welcome to it. If you got any questions about it, let me know. And that's it for now.
Very good. Okay, well, we've gained a few more people here. Let me get a start here. Well, do we want to spend some time on Telescopius and target planning?
Can I ask Rick a couple questions?
Sure.
So Rick, that C-Tech, that charger, C-Tech, was it?
Yes.
Basically, you plug that in like in your garage or wherever, and you just leave it plugged in. You don't have to worry about anything.
I don't.
Okay, that's nice. My other question is, I'm going to look at that schematic, but I'd be interested in like what readouts can we get on the input and output on those LEDs you have? Does it show volts and amps?
Oh, you're talking about the little voltage regulators, those boost inverters?
No, I'm talking about displaying what's going out of the battery and what's coming in, like in terms of, do you have an indicator that?
Oh, yeah. You know, I don't have a current monitor on there, but let me show you what I do have that I use, and it wasn't in that pack of where'd it go? Give me just a second. I'll show you exactly what I do, because there's a cute along with all those Anderson power connectors, right? I've got a little voltmeter, amp meter use thing that will plug in line in that to read all the currents and watts and all the power use functions. I don't leave it plugged in all the time. Hold on. Sorry.
That's going to take your time. I think part of the fun of building my own battery box is knowing what volts are going out, what amps, and what's going in while it's charging.
Yes. And West Mountain Radio's got a lot of that kind of stuff too, that link. Find MAS. That's it. And thanks for asking that question, because I am going to update this presentation. Okay. Let me share the screen again real quick. All right. So this is just a little box that goes in line with Anderson. It's got a lead coming out either end of it, and it's got Anderson power poles on it, and it's a watt meter power. This is source and load. So the source, my battery goes here. This is in this condition right now. This is on my ham radio. In fact, it's over here on my ham radio power supply thing right now. So it's 1.2 amps at idle, 16.8 watts, 14 volts out. So
that's pretty cool.
Yeah. And on this one, to see what you're putting in, you'd have to turn it around, right? But that kind of thing. And this stuff's all over eBay, and Amazon has got this kind of thing. They're handy.
Well, that would come in handy because like the ASI Air has a 5 amp limitation, and you can damage it if it goes above that. So you can monitor that. Yeah.
Yeah, I'm currently, in fact, I'm going to, I haven't set this up yet, but I've got the new ASI mount, and it's it apparently takes about 5 amps or less to run it.
Mhm.
And I've got two basically 7 amp voltage controlled outputs on my battery. And I don't know that I actually need to run both of them. I might, but I don't know that I do. But I'm going to do some testing to figure that out.
Mhm.
Right now, I'm running the ASI Air separate from the mount. But the mount actually has an output to go to the ASI Air and run it.
Mhm.
So,
Excellent.
To add to what Rick said, if you guys use lithium ion, you might want to watch out for what's called thermal runaway. Because if you overcharge a lithium ion battery, it will go into what's called thermal runaway and cause bulging and fire. So that's why you can't overcharge a lithium ion battery.
if you ever
That's
got
why-
a lithium,
What?
if you've got a lithium ion and
Yeah.
either it's case or a lot of them come, you can get them not cased, but if they start to bulge, get rid of it.
Yeah, you have to watch how you get rid of it as well too.
Right.
Also, if you get a lithium ion or a lithium iron phosphate battery without the watt hour, reach out to the manufacturer with the model number. By international law, they have to provide a safety data sheet or a UN 38.3 test report. Okay, on their website, that will give you the watt hour for that battery.
Cool.
Required by law when they ship it.
More questions?
Thanks for the questions. I'll update my presentation with my little device there. I forgot about that.
Okay. More questions for Rick? Are we done with this subject? Okay, let's say we're done. Do we? So the next question is: do we want to go into Telescopius or save that for next month?
Save it for next month. That's going to.
I just heard Morris.
Morris says save it for next month. So it's 8 o'clock. So he has a point.
Well, we normally go an hour and a half to 2 hours.
Okay.
I'm okay either way. I mean, the customers are the people on the screen. So why don't we just do that? Why don't we let me have the screen for a second and just take a look at the future agenda items. Is this what this is? No, that's not.
So while Meryl's doing that, Rick, I got another question. You have a PDF schematic. Does it involve soldering? Oh, everybody got muted.
Oh, did they?
No, I muted myself. I thought my dog started barking again.
Okay.
No, absolutely not. In fact, if you ever get into boat wiring, I bought a boat one time. Basically, at one time, had to rewire the whole freaking thing. You never solder joints that are going to go into a rugged, rough environment. You want to crimp connect everything. It's a mechanical connection, and it's just better for the ruggedness of everything. So no, everything in that is crimped.
Okay, I'm going to talk to you about that when I get going.
All right. I've got the power pole tools and all the different crimp tools. So in fact, I think I have some spare parts because some of the things I bought came in pairs and I only needed one.
Okay.
Mm-hmm.
All right. So we'll I guess the consensus, in absence of a lot of conversation, is to hold off on the Telescopius till next month or next time. Is there, looking at the future agenda items we've captured in the past, are any of those things we want to add to the Telescopius conversation or meeting?
I think guiding is going to be a meeting of itself.
You think so?
Yeah.
Okay.
I think you need
Can
a full
be.
hour and a half for that.
If we get okay, well, we can do that. do we want to do it next in June or again, the customers are the people in the audience, and if it's not a good use of time every month, we can do it every 2 months or however often we want to. We don't want to force this, but we want it to be something that's valuable. Anybody have any opinions on that?
I'm free every month. I'm willing to learn whatever you guys are willing to teach.
Okay.
You know what I'm gonna be interested in? Not that I count, but when is ASI gonna come out with their field rotator?
It's I know 2 people testing it right now. It
Really?
is close. They took pictures of it and sent it to me, and they said, "Don't tell anybody." And I just told everybody, and this is going on YouTube. And this is going on YouTube. I have photos, and it looks. There's some things I don't like about it. It looks pretty thick. So those of us who OAG, I'm wondering if I can even do it. I have 20 millimeters. Adding 20 millimeters to the train is going to be a big deal for me.
Yeah, the back end of my telescope from the back of the mirror to the focuser has got 3 screw-on sections, so I could lose a whole section and
yeah, you're set. If you're wide field, like Cameron and I are pretty wide field.
Yeah.
Well, I'll probably have to go to a guide camera to get it.
And what I really want to know about is, what does that buy me? What it buys me is the ability to set up in alt-az mode.
Yeah.
And polar alignment, right? Just go find a couple of, do some plate solving and tell it where it's at and say, okay, now take pictures.
Right. It's
or not. So that's my question.
Yeah, that's going to be one. That's not why everybody's going to buy it, though. They're going to buy it because I shot something 2 years ago, and I want to add some hours to it. I don't have to think anymore. It's going to.
You also have the advantage if you do a meridian flip, you can go right back to the same place, the same guide star.
Yeah, same guide star.
Oh, that's neat.
Yeah. So what it'll do, Rick, is it'll look at your actual image that you took, and it's going to get the angle of rotation because it's going to do some plate solving. It's part of the plate solving routine.
Okay.
It's going to rotate your camera perfectly to where it was 2 years ago, so there's no crop, and when you're doing mosaics, that's going to be that's going to be an interesting talk. When you're doing mosaics, this tool is going to be unbelievable.
Hey, Steve, you have any hint of what the price is going to be?
No, my buddies are telling me that the factory are saying, "Man, we got to get this thing cheaper."
Yeah, Memphis Astronomical group people meeting.
Puneet, did you get a prize?
I'm extremely sorry. I didn't know that I was not on mute.
Okay, no problem. Yeah, so I bet it's gonna be like $350, Rick, or somewhere around there. We'll see.
Cool.
Yeah.
That
So
sounds terribly expensive.
Mhm.
Okay, so I put on the future Genom ASI rotator
cool.
sometime. So so
Or rotators in general, I think the PC people, they already got that going. Like you had one, didn't you, Merrill, before you got your
yes.
Alt-Az?
Yeah, I used it just the same way you're describing. It was get the brand name, but it made taking images before and after the meridian exactly the same. And I never used it for the alt-az. I do use it, the one with the CDK. It's in alt-az mode now, and so I don't have to worry about polar alignment or guide stars or anything.
Mm-hmm.
So there's the real advantages if you can get it fine-tuned and right on.
For that guiding one, what I'm going to do is, when I have time, is and clear skies, which don't exist in Memphis, but
They don't.
I'd like to get I'm going to get some video of ASI air guiding because I've learned a lot about it. And then I think somebody else needs to do, Push Here Dummy 2 on a PC. That might be a good talk.
Okay, so who's got a calendar for June? We want to shoot for June this time?
For guiding, you mean?
No, for Telescopius.
Yeah, that'd be good.
So what is that?
14th to the 21st.
Is the third win? Yes, the 21st.
21st.
Okay. Okay. Well, good job, Rick. That was a good presentation. And,
It was.
I think that when we get into this discussion here, I think that will be a fun one, particularly for some of the new folks that are getting started in it. So we'll just say that for June 21st, and we'll sign off for this evening. And unless somebody else has anything else to discuss.
Another agenda item that I'd like you to present, Merrill, would be a Pix Insight with Russell Croman's. You just redid. Remember that contest we did, and you just redid that galaxy recently. I forget what it's called.
Oh, 253 NGC 253.
Yeah, I mean it was really quite amazing. And it was a vast improvement for what you did with, the existing Pix Insight tools. And I think that would be interesting to see what those tools are doing.
So RC tools. Okay.
Yeah.
Well, what I found, did it help processing in terms of results? Yeah, some, because you didn't have to finesse it nearly, hold your tongue just right to get the result. But the thing that really helped was time.
Right, which we all want.
Is once you do the iterative approach to the processing, it really made it go a whole lot quicker. Yeah. Okay. Well, it's on the list.
Okay.
Okay. Anybody else have anything before we sign off for this evening? Nope. Now I got to figure out how to stop sharing here, and we'll stop recording.